Good morning, students. Today we'll discuss about LP1 practical of high performance computing subject. Myself, Professor Manohar Kodmelwar, Assistant Professor in Computer Engineering Department, TSSM, Dhirubhai Sound College of Engineering and Research. Narek. So, today we are going to discuss about the vector and matrix multiplication as well as vector and matrix operations. What operations can happen between this matrix and vector matrix. That is a problem statement. Learning objective is what we have to implement this vector and matrix multiplication in parallel. That is what using the parallel processing. That is what the objective. Then outcome is what when we use this what we consider as a parallelism in this particular programs. So we may find that you will understand how the parallelism is implemented in this particular sequential program normally will execute. So how the number of threads are created and they will execute parallelly this code. So that students will understand after the completion of this particular program, whatever we are going to write. Then we are going to see this three operations, that is the addition of two large vectors, then multiply vector and matrix, then multiply n by n matrix by using parallel programming. That is important. So in addition of two vectors, what we'll do first, we'll take the first vector and then second vector in array, and then by using our hash pragma OMP parallel, this statement is most important, which will create the number of threads to execute parallelly. So this two vectors are executed in parallel and we get the result in the third vector. So that we are going to study by writing the code and after getting the output of that code. Then second is what? Multiply vector and matrix. Now we have to use here one vector and another is a matrix. So just we have to see that the rows and columns, according to that, it will what we consider as the multiplications will happen. So in the first array we will take the vector, right? Which we consider as the two rows and one column, and in the second matrix we will take a particular three rows and two columns, right? So now this it will match for the multiplication, and we'll use this OMP directives for parallel processing, hash pragma OMP parallel, which will create the number of threads to execute parallelly this code, whatever we write, and we get the output in the particular third array, the result of this vector and matrix multiplication. The second program we are going to write. The third program we are going to write is the multiplication of two n by n matrices of size. Here both the matrices have the same particular rows and columns will be there, and we'll first accept the first matrix, then we'll accept the second matrix. So in our program, instead of accepting number of times, we have used some random functions which will directly insert some values randomly at the in the row and column in the two matrices. Then we'll use this most important is OMP parallel, hash pragma OMP parallel, which will create the number of threads to execute the particular block of code. Somewhere we have also used the OMP single, where a single thread is used to execute the particular block of code. And somewhere we have used pragma OMP parallel for private, which are again what we consider as the having its own instance of variable, each thread having its own instance of variable. So these three directives we will use in our particular program to execute parallelly this matrix multiplication. And also we'll see that how much time that code has took for executing this particular program. So, and we'll display that output as well as the multiplication output as well as the time taken by this code to execute this n by n matrix, right? So let us write the code and execute the code for addition of vectors, right? So we'll write first include libraries. stdio.h. Then we'll write hash include hash include stream. Then we'll write C standard libraries which are required. stdlib. Then there is the most important, that is include omp.h to get the directive whatever we are going to use in our next lines, what we consider as for parallelism, using namespace standard. Now let us define some variable which will be used for storing the array values. Define max as 100 elements max it can store. Then let us write the integer main. Here what we have to do is that integer will declare some arrays a of max comma b of max comma the result will be stored into the C array, there is C max. After declaration, what we'll do is that we'll create the first vector, that is we can write as for display printf here we will write /n, that is first vector, right? Then now we will take the now what we have to do is that we have to take the first matrix. So instead of giving the first matrix, what we'll do, we'll randomly store the numbers. So by now we have to run the code which is important, that is parallel also. So let us take hash pragma. This is most important to run the code parallelly. OMP parallel for. I'll write the code which we want to execute parallelly. For I equal to 0, I less than max, I plus plus. After initialization of this loop, now we'll take this two brackets. We will here take the first array in that first vector we can consider. So here a of I equal to, we will use a random function that it will insert %. So it will insert randomly values up to the max, right? Then after the first vector, now we will write again hash pragma. Instead of writing, let us copy this. Complete code for second vector. Here we will write b of I, right? So here again parallel code we want to run. Max up to X. B will be stored now. B is ready. Now third, what we'll do is that again we can have the particular C array which will store the values, that is the A of I plus B of I here. Right. According to map, C of I equal to A of I plus B of I. Now, so this is what for we can consider as a vector addition. Rest is what we want to display the result. That is again we will take a for loop. You will display the C of I. So this is what the code for the addition of two vectors. So let us see the results. What results we will get from this particular code. Just we have now next we have to write the. Now we have written the which we have written. So now G++. So we have stored our file into the bin directory. G++ minus F open MP. File name we have to write add underscore vector dot C. Output file will create and it's EC. Now it is executed. No any compilation errors are there. Now we'll execute. See here, if you look at this output, we have to for the 100 values. So this is a first vector, and this is the second vector we have took. And from that two vectors, we got the addition. See here, now first vector contain 41, and second vector contain 382. See 41 and 382. So the addition is 3 and 2 and C 423. So like this we have added. So parallelly this code is executed by our program. This is for the addition of. So you can check for another also. See 467 and 421. So you will get the 888. So like this we are going to add the vectors. Right. So for minimum values also we can check. So just we have to reduce the number of array values so that you will get the reduced value. So like this we have A of B, A of I, B of I we added and we will get the result. So thank you.